Hi all, today we are going to solve the search insert position problem, which is a Leetcode easy problem. Given a sorted array and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You may assume no duplicates in the array. You will be given a sorted array and a target value. You need to return the index if the target is found in the array. Otherwise, you need to return the index where this target value is going to go and sit. So here in the example 1, we have given a array with values 1, 3, 5 and 6 and the target value is 5. Hence the target is available inside this array. We can return the index of that target. In the example 2, we have given array values 1, 3, 5 and 6 and the target is 2. Because the target is not found in the array, we need to return where this target is go and sit in the array. So generally this target is go and sit after 0th index. So we need to return the index 1. So here in the example 3, we have array values 1, 3, 5, 6 and the target value is 7. This target is not available in this array and we need to find where this target is going to go and sit. It will sit at index 4. Clearly, we can solve this problem by performing the linear scan on the sorted array, but the time complexity of that approach is O of n. We can reduce the time complexity to O of log n if we can perform the binary search on this sorted array. But applying binary search directly won't solve this problem because in case when we don't find the target in the array, we need to return a index where the target go and sit. Hence, we need to tweak the binary search or modify the binary search so that if it finds the target, it will return the target index. Otherwise, it has to return the index where this target is go and sit. So for that, let's try to understand the examples carefully. Let's take a look at example 1 where we have array with values 1, 3, 5, 6 and 7 and the target is 5. Here in this case, let's try to apply the binary search using the iterative approach where we have two pointers start and end. Start is pointing to 0th index and end is pointing to last index which is 4. As per binary search, now we need to find the mid index, mid pointer. So here the mid index is 2 and the mid element is 5 and the 5 is clearly equal to target. So we found the target over here. Hence we can simply return the mid index which is nothing but 2 here. Let's look at the another example where we have array with values 1, 3, 5, 6 and 7 and the target is 2. So if we apply binary search here, as usually start and end pointers are pointing to 0 and 4 respectively and the mid pointer is pointing to index 2 and the mid element which is 5 is clearly greater than the target element. Hence, as per binary search, we need to update the end pointer to mid index minus 1. Now again perform the binary search. Let's calculate the mid pointer which is pointing to index 0 and the mid element which is 1 is clearly less than the target element. Hence we need to update the start pointer to mid pointer plus 1. Now again perform the binary search, calculate the mid pointer which is pointing to index 1 here and the mid element is 3 which is clearly greater than the target element. Hence we need to update the end pointer. Because the start and end pointers are crossed each other, we can stop the binary search operation here. Because we do not find the target element which is 2 in the array, we have to return the insertion point where this target is going to go and sit. In this example, our target is 2. So if we would insert the target in this array, we would insert at index 1. So we can clearly say that if our target element is not found, then we can return the start pointer's index. In this case, 1. Let's take a look at example 3, where we have array with values 1, 3, 5, 6 and 7. The target is 8. Let's apply the binary search over here. As usual, start and end pointers are pointing to 0 and 4 respectively. Let's find the mid pointer, which is at index 2, and the mid element is clearly less than the target element, hence we need to update the start pointer. Now again apply the binary search and find the mid pointer. Mid pointer is at index 3 and the mid element is 6, which is clearly less than the target element, hence we need to update the start pointer again. Now again apply the binary search and find the mid pointer. Mid pointer is now at index 4 and the mid element is clearly less than the target element, hence we need to again update the start pointer. Now start pointer and end pointers are crashed each other, hence we need to stop the binary search operation. In this case also we did not find the target element in the array, and we can clearly see that if we can return the start pointer's index, that would be the insertion point where our target is going to go and sit. Let's look at the another example where we have array with values 1, 3, 5, 6 and 7 and the target is 0. As usual, start is pointing to 0th index and end is pointing to 4th index. Now apply the binary search, find the mid pointer, which is pointing to index 2, and the mid element is 5, which is clearly greater than the target element. Hence we need to update the end pointer. Now again perform the binary search, calculate the mid pointer, which is pointing to index 0, and the mid element, which is 1, is clearly greater than the 0, our target element. Hence we need to update the end pointer. Because the start and end pointers are crashed each other, we can stop the binary search operation. In this example also, the target was not found. So we need to find the insertion point. So by seeing this example, we can clearly say that our target is going to sit at index 0. So we can clearly say that if we can return the start pointer's index at any time, that will be the insertion point for the target. So let's code for this. First of all, let me take start and end pointers. Start is pointing to 0 and end is pointing to last index. Now start length -1. Now we need to perform binary search until the start and end pointers are crashed each other. So start is less than or equal to end. We need to perform binary search. To perform binary search, first we need to identify mid pointer. So mid pointer we can calculate using the start and end pointers. Now let's check our target is there at the mid pointer or not. If our target is found at our mid pointer, then we'll simply return the mid pointer, mid index. Otherwise, we need to compare our target with the mid element. So nums of mid is greater than our target. Then we need to update the end pointer to mid -1. Otherwise, we need to update the start pointer to mid +1. We came here means the target was not found with the binary search operation. In that case, as for our analysis, we need to return the start pointer index. So let's return start and let me submit. Success. One more thing I want to show you. So let's go to examples again. In the example 2, we have array with values 1, 3, 5, 6 and 7 and the target is 2. Hence the target is not found. With the help of binary search, we just return the start pointers index in this case. And also in the example 3 also we return the start pointer index because the target element 8 was not found. And in case of example 0 also, the target element 0 was not found this in the array. We return the start pointers index. So if you observe carefully, if we can return the end pointer index plus 1 also, we can solve this problem. So let's try this as well. So instead of start, let's return the end pointer index plus 1 and let me submit. Success. That's it about this problem. Thank you for watching. Please like and subscribe for more videos like this. Thank you very much.